For this question, we want to use the product rule to expand the logarithmic expression, and whenever possible, evaluate the logarithmic expressions. We want to simplify log base 6 of 1296x. And on this example, we're going to look inside of the log to see what operations we have going on. If we want to expand, we look for the operations of multiplication, division, and we look for powers. So inside that logarithm, we have 1296x, and that is 1296 times x. So we have the operation of multiplication inside the logarithm. Multiplication is often called the product. So we're going to use the product rule for logarithms to expand. So when we have the product inside the logarithm, what we do is look at each factor, a factor of m and a factor of n, and that factor of m is inside a log, and that factor of n is inside a log. And we add those two together. So the adding is key to the product rule. With the product rule we add, the quotient rule we subtract. So for our example, our factors are 1296 and x. We're going to do log base 6 of 1296 plus, we get that plus from the product rule, log base 6 of x. Now in the instructions here, it says to expand, and this step that we've done is expanding from a single log to multiple logs. But it also says whenever possible, evaluate the expressions, the logarithmic expression. So here in the first term, we have log base 6 of 1296. That's log of a number. So when we have log of a number, we want to try to simplify that. So what we do is we look to our base of 6, and we want to start thinking of powers of 6. 6 to the first is 6. 6 to the second is 36. 6 to the third, that's 216. And 6 to the fourth, that I don't know off the top of my head, so I'm going to get my calculator out. And 6 times 6 times 6 times 6 is 1296. So that is the number that's inside the log. And so that means that log base 6 of 1296 is 4. And we've now simplified or evaluated that logarithmic expression. And we get an answer of 4 plus log base 6 of x. On this example, we want to solve the logarithmic equation. 2 log base 5 of 6 minus x minus log base 5 of 5 equals log base 5 of 45. So to solve this log equation, there are two main methods that I typically look for. And the two methods are to convert to an exponential, or to use what's called the property of equality. And these two methods can kind of be boiled down, or when to use these methods can be boiled down to whether you see an equation with all logs or whether you see logs and other types of terms. And in this example, I see every term with a log base 5. So I would say that this one has all logs. When it has all logs, you're going to use the property of equality. When it only has some logs, so if it has some other terms besides logs, you want to convert. Now, when you convert, you need to have a single log on one side. And when you have the property of equality, you want to get something that looks like this. You want to have log base b of something, let's say u, equals log base b of v. You want a single log on the left and a single log on the right. So I have to use my expanding and condensing properties to get it to this state so that I can use the property of equality. So to get it to that state, I'm going to use the power rule for logs to move that coefficient into the exponent. So that would give log base 5 of 6 minus x squared minus log base 5 of 5 equals log base 5 of 45. Then I'm going to use the quotient rule. I'm going to use the quotient rule because this is subtraction. Using the quotient rule to condense, and that would be log base 5 of 6 minus x squared over 5. So with the quotient rule, I'm going to divide these two inside the logarithm. And now I have it with the log, same base on both sides. And the property of equality says if you have this situation, what's inside the log on the left is equal what's inside the log on the right. It allows me to really simplify this equation. So I get 6 minus x squared over 5 equals 45. Now I want to solve this equation. I can solve by multiplying by 5 on both sides. That's 6 minus x squared equals, off the top of my head, I don't know what 45 times 5 is. That's 225. And I know that that's a perfect square. I'm going to take the square root on the left and the square root on the right. And the square root and the square cancel each other out. We're going to get 6 minus x on the left. I'll gain a plus or minus symbol on the right. And square root of 225 is going to give me, I believe, 15. Let me double check. 15 times 15 is 225. Then we're going to solve for x. I'll subtract 6 on both sides. That's negative x equals negative 6 plus or minus 15. I'll divide both sides by negative 1. That's x equals 6 minus plus 15. So our two answers are 6 minus 15 and 6 plus 15. 6 minus 15 would give 9, and 6 plus 15 gives me 21. With every log equation, you do need to check your work. We're going to check in the original equation. So let's check. X equals 9. We have 2 log. I've made a mistake here. I apologize. 6 minus 15 is a negative 9, not a positive 9. So it's negative 9. 2 log base 5 of 6 minus negative 9 minus log base 5 of 5 equals log base 5 of 45. So we're really only checking this one part here to make sure that we don't take the log of a negative. 6 minus negative 9 is the same thing as 6 plus 9, and that is 15. So we're going to be able to keep that solution. And then we're going to check the other one. Let's check 21. And that would give 2 log base 5 of 6 minus 21 minus log base 5 equals log base 5 of 45. So once again, we're checking this part right here to see if we get a positive. If it's a positive, we keep it. If it's a negative, we have to throw that solution away. 6 minus 21 will give me negative 15. So we're going to have to throw that solution away because the log of a negative is undefined. So our only solution to this equation is negative 9.
Thank you for checking out my videos. Have a great day.